Now we're going to look at another algebraic method for solving a system of equations, and this is the elimination method. The elimination method is a powerful method used to solve systems of equations and works well when none of the coefficients of the variables is 1 or -1. Fundamental idea behind the elimination method is to continue replacing the original systems of equations by a system of equivalent equations until the solution is reached. Now, this method uses two properties of equations which we should be familiar. We can multiply both sides of an equation by any constant except 0, and we may add equal quantities to both sides of an equation without changing the solutions of the original. Now, solving a system, here's the steps I've got to go through. First thing, write both equations in the form ax plus by equals c. So that means all my variables are to the left and my constants to the right of the equal sign. Look to see if the coefficients of one of the variables in one equation is the opposite of the coefficient of the same variable in the other. If the coefficients are not opposites, multiply one or both equations by constants, by numbers, that will make the coefficients opposite. Add the equations together to eliminate one variable and solve for the value of the remaining variable, because when we add, we're going to get our equations condensed down to one equation with one unknown that we can solve for. Now, once we've done that, then we've got to substitute that value that we found in step 5 back into either of the original equations and solve for the remaining variable. Or, if you have to, repeat the process eliminating the other variable. That's legal too. Then write the solution as an ordered pair. Now, use elimination to solve each system. So, first thing, they are written in the same form. Scan through your x's and your y's. Now, if you'll notice, my y's have coefficients that are opposite, so I can go ahead right now and add them. So, draw a line and add. And if you'll notice, I'm down to a very simple linear equation, and I'm going to divide both sides by 5. So I get x equals 2. Now, which equation do you put it in? It does not matter. I usually go back to see which one has the smallest numbers. So if I put 2, if we put it, say, into this one, let's see what we get. Substitute in. This would give me 4, and subtract 4. My y value should be 4. So my solution would be in parentheses 2, 4. Check it in the other equation, and that would be a way that you could double check yourself and make sure that your answer is correct. Now, in this one, as I scan through, in order to get my x's to the same place where they would eliminate, the first place that the number that they would have in common would be 20, so I can multiply the top one by 4 and the bottom one by -5. I could do that. I could multiply the top by -4 and the bottom by 5. It does not matter. If the signs with your coefficients, or the signs of your coefficients, are the same, somebody's got to be multiplied by a negative. Now look at my y's. To get my y's to a place where they would eliminate, all I would have to do is multiply this bottom equation by 2. So, this is how I normally write it. My intentions is to multiply through by 2. Let me get rid of that. And that would give me another set of equations. Multiplying through by 2. Biggest thing here you've got to remember is make sure you multiply the constant. I have some people that forget that. So since my 6's are opposites, I draw my line. Add my x's, add my constants. I get 13x equals 0, or x will equal 0. Substitute this back into one of the equations. I chose the bottom one. So I would have -3y equals -2, or y equals 2/3. So my solution would be 0, 2/3. And that's it for the elimination method. Thank you. Bye-bye.